Hello friends, welcome back to channel Maths with Sim. We are here with the next video, obviously related to trigonometry again, chapter ICSE board 10 standard heights and distances. In the previous video, the angle of elevation, the angle of depression was clearly explained. So let us directly start with the problems. The first one, question says, from the top of a lighthouse 100-meter high, the angles of depression of two ships are observed 48 degree and 36 degree. From top of a lighthouse 100-meter high. So this is a lighthouse. Obviously angle of depression is given, and angle of depression should be in relation to line of vision. It is given in the question, angle of depression of two ships are observed 48 and 36. So these are the positions of the ship C and D, 36 and 48. So this angle is 36 degree and this angle is 48 degree. Lines are parallel. So if this is 36, this will be 36 and this will be 48. What is given is the lighthouse 100-meter high. What they want? Find the distance between the two ships in the nearest meter. There are two conditions. I am going to consider the first one. The ships are on the same side of the lighthouse. Ships are on the same side of the lighthouse. So let AB lighthouse, AB is 100 meter, C and D, position of ships, angle of depression 48 degree, 36 degree, angle EAD will be equal to ADB equal to 36 degree, EAC equal to ACB equal to 48 degree. What I want to calculate here is find the distance between the two ships. So I want to calculate CD. Obviously for CD we will require BD, we will require BC, we will subtract and get CD. So in right angle triangle ABC, tan 48 is perpendicular side upon base or opposite side upon base. Tan 48 का value we will get it from the tangent का table. Value is 1.1106, AB is 100 and BC I want to calculate. So BC will be 100 upon 1.1106, which is 100, 10,000 upon 1106. Yeah, 1.1106, it is 1106, right? So when I divide this, it will be 0.90 041. So basically our answer will be 90.04 meter. We got this as BC. I want BD. In right angle triangle ABD, tan 36 again perpendicular upon base. Let us find tan 36 ka value. .7265, 100 upon BD. So BD will be 0.7265, 100 into 7265. Is it okay? Now the calculation part. 7265 ones are 1.365, which will be 136.5 meter. We got BD. What we want is distance between ships, which is equal to CD, which is BD minus BC, which is 136.5 minus 90.04, 46.46 meter. In the question they have said round it off to nearest meter. I'll just check the calculation again. Seven, 6. .56 nearest meter is 48 meter. If I take the second case of the question, where the question says find the distance between the ships when they are on the opposite side of the lighthouse, what will change? We will take C here, D there. Both calculation we have to add, not subtract. That's the only change which will take place. Next, question number 2. Question says two pillars of equal heights stand on either side of a roadway which is 150 meter wide. Important, they are of equal heights. So two pillars of equal heights stand on either side of the road. This is 150 meter, A, B, C, D. AB is equal to CD. It is given. At a point in the roadway between the pillars, the elevations of the tops of the pillar are 60 degree and 30 degree. They have not mentioned with which pillar it is 60 or 30. You can take any because they are of equal heights. Also, the position not mentioned. Let us take this position. Anywhere you can take it. This total is 150 meter. So this elevation and this elevation. This is 30 degree and this is 60 degree. They have given. Find the height of the pillars and the position of the point. Position of the point means at what distance is E from B or D, and also the height of the pillars. So let us write AB and CD are pillars. AB is equal to CD. Angle BEA is 30 degree. Angle CED is equal to 60 degree. As we don't know the position of E from B or from D, any one dimension you take as a variable x. So let BE is equal to x meter. So DE will be 150 minus x meter. So in right angle triangle ABE, I'll go for tan. Why tan? Because the base is x and the opposite sides of these two angles or the perpendicular sides of these two angles are equal. So tan 30 will be AB upon BE. Tan 30 is 1 by root 3 AB and BE is x. So AB is x upon root 3 meter. Let us mark it as 1. In right angle triangle CED, tan 60 again will be perpendicular side upon base, which is root 3 CD, and DE is 150 minus x meter. It is given in the question that AB is equal to CD. So AB is equal to CD because the pillars are of same height. So automatically, okay. CD will be root 3 into 150 minus x meter. I'll name this as 2. Now because they are of the equal heights, we can take the equality, substitute. What is AB? X upon root 3. What is CD? Root 3 into 150 minus x. Cross multiply, it is 3 into 150 minus x. When we expand it, we will get x is equal to 3 into 150, 450 minus 3x. So x plus 3x is 450, 4x is 450, x is 450 upon 4. 1, 1, 112.5. That is x. Next what you want is AB or CD. Either you take AB or CD, your choice. Both will give me the same answer. So height of pillar will be root 3 150 minus x, root 3 150 minus 112.5, root 3 into 37.5. Multiply 37.5 into 1.73. We can keep the answer in root 3, but normally we substitute to multiply. Five. 64.95 meter. Now, sometimes you can state this as 112.5 from AB, 37.5 from CD. It depends from which pillar the distance is calculated, right? It is not the midpoint, so obviously two different answers. I hope both the questions are clear. Let us move on to the next one. Next is question number 3. The third one. Question says, a man on a cliff observes a boat at an angle of depression of 30 degree, which is sailing towards the shore at the point immediately beneath him. 3 minutes later, the angle of depression of the boat is found to be 60 degree. Assuming that the boat sails at a uniform speed, you have to find how much more time and also the speed of the boat. Firstly, the man on a cliff observes a boat at an angle of depression of 30 degree. So, a man on a cliff AB is the cliff. This angle is 30 degree. So this also will be 30 degree. A man on a cliff observes a boat at an angle of depression of 30 degree sailing towards the shore. 3 minutes later, the angle of depression is 60 degree. So this angle is 60 degree. So AB, cliff, angle of depression 30 degree and 60 degree. So angle EAD equal to ADB is equal to 30. Angle EAC equal to ACB is equal to 60. This distance is covered in 3 minutes. CD is distance covered in 3 minutes. It is mentioned in the question, 3 minutes later the angle of the boat is found to be 60 degree. So what we want to calculate here, how much more time it will take to reach the shore. Means to travel BC, how much more time the ship will take, and also the speed of the boat in meter per second if the height of the cliff is 500 meter. Now I want to calculate time taken to travel this much. So what we will do, AB is a height common to two triangles ABC and ABD. So in right angle triangle ABC, tan 60 is AB upon BC root 3 AB upon BC. So AB is BC root 3. We are not considering anything as BC. Let us keep it in BC form. In right angle triangle ABD, tan 30 will be AB upon BD. Tan 30 is 1 by root 3. Again AB as it is, BD also as it is. So AB is equal to BD upon root 3. Both are equal to AB. So we can equate. So what we get is BC root 3 is equal to BD upon root 3. So thrice BC is equal to BD. CD is a distance covered in 3 minutes. So slightly unitary method. If CD is covered in 3 minutes, BC will require how much time? So we can just convert this in relation to CD and BC. How will I convert it? I can write BD as BC plus CD. So it is twice BC is equal to CD. So BC will be CD upon 2. So if CD requires 3 minutes, BC is half the distance, half the distance of CD, means the time required will also be half. BC is half distance of CD. Therefore, time required will be 3 by 2, 1.5 minute to cover this much distance. Now the second part, you can write here first. Second part, it says find the speed of the boat. Find the speed of the boat in meter per second if the height of the cliff is 500 meter. Height of cliff 500 meter. Height of cliff is given by AB. AB is 500. I want speed. I know the distance, I know the time. I want speed. I can take any of the two triangles. This height is given, angle is known. You can take BD, the total distance also, to calculate, because we will require either BD or we will require either BC to calculate the speed, right? So let us go with AB is equal to BD upon root 3. So 500 BD upon root 3. So BD will be 500 root 3. This much meter is the distance. And how much time is required to cover this much distance? 3 plus 1.4, 4.5 minute. So distance is 500 root 3. Time is 3 plus 1.5, 4.5 minute. We want speed. The relation of distance, time and speed we will use to calculate the speed. Speed is distance upon time. So distance is 500 root 3 and time is 4.5. This is meter per minute. I want meter per second. So it is 500, 1.73, 4.5 meter per second. 1 minute is 60 seconds. Now we do the cancellation. .20 meter per second will be the speed of the boat, and it's a uniform speed. Is it okay? So first calculate the time required for this particular distance to cover. What I have done here is I have taken BD as the distance and calculated BD. You can go with BC also by taking tan 60 or this relation, calculate BC and then proceed by using the time as 1.5 minutes. Still same answer because it is uniform speed. Let us move to the next one. A person standing on the bank of a river observes the angle of elevation of the top of a tree standing on the opposite bank as 60 degree. So a person standing on the bank of a river observes the angle of elevation of the top of the tree. Say this angle is 60 degree, angle of elevation. When he moves 40 meter away from the bank, he is moving 40 meter away from the bank. The angle of elevation obviously will change, and the angle of elevation from the bank is 30 degree. Question says, find the height of the tree correct up to 2 decimal places and the width of the river. Find the height correct up to 2 decimal places and the width of the river. We want the height of the tree. Let AB, tree, angle ACB 60 degree, angle ADB 30 degree, CD is equal to 40 meter because the person has moved 40 meter away from the tree along the shore. Let us this distance take it as x. Otherwise constantly throughout the problem BC we will have to mention. I want height of the tree. So obviously in right angle triangle ABC, again the perpendicular side is common, so I'll go for tan 60, which is AB upon BC root 3 AB upon X, so AB is X root 3 meter. In right angle triangle ABD, again tan 30, which is AB upon BD, 1 by root 3 AB upon BD is X plus 40. So what is AB? It is X plus 40 upon root 3. Both are equal to X. We can equate them. So X root 3 is X plus 40 upon root 3. Cross multiply. 3x is X plus 40. So 2x is equal to 40. So X is equal to 20 meter. So BC is 20 meter. So basically we calculated width of the river. Width of river is 20 meter, which is the second question. Find the width of the river. Now I want AB. Either I can use this relation or I can use this relation. AB is X root 3, which is 20 root 3, 20 into 1.73, 6, 4, 34.60 meter. Therefore, height of tree is what they have said. Correct up to 2 decimal places. 34.60 meter. I hope whatever we have done till here is understood. Yeah, any doubts you can always post it in the comment. Let us move to the next one, that is question number 5. Question says the length of the shadow of a tower standing on a level plane is found to be 2y meters larger when the sun's altitude is 30 degree than when it is at 45 degree. Prove that the height of the tower is given. Nothing to find, it is there. The answer is there in the question. Fifth one. Question says the length of the shadow of a tower standing on a level plane is found to be 2y meters longer when the sun's altitude is 30 degree than when it is 45 degree. Now length of the shadow of a tower. So this is a tower AB. Two angles obviously will be there because the shadow of this will be projected on the ground. So two angles. Now it is the shadow by the sun. So to mark this we can't directly do it. Why? Because the sun rays will travel from the top, then only a shadow is formed. So obviously it will be in relation to angle of depression. (45, 30). So this will be 30 and this will be 45. When the sun rays will travel, the shadow of the tower will be placed here. what they have given there is the relation between BC and BD, and what we want to prove is the height of the tower. They say prove that height of the tower is y bracket root 3 plus 1. What they have given here is the relation between BC and BD. I'll repeat the sentence. The question says the length of the shadow of a tower standing on a level plane is found to be 2y meters larger. It is greater when the sun's altitude is 30 degree. So this altitude is 30 degree. So BD is greater than BC, and by how much? By 2y meter. So AB, the tower, BD minus BC is 2y meters. It is given. We want to calculate the height. So in right angle triangle ABC, again AB is a common side, 45 is given. I am interested in BC, so obviously I'll go for tan 45 is equal to AB upon BC. Tan 45 is 1, AB upon BC, so BC is equal to AB. That is the first relation. Second, in right angle triangle ABD, again tan 30 will be AB upon BD. Tan 30 is 1 by root 3 AB upon BD. So AB is equal to BD upon root 3. That is my second relation. But AB is equal to BC. So I can write BC is equal to BD upon root 3. So BD is BC root 3. We got BD in terms of BC. This relation is known. BD minus BC is equal to 2y. So BC root 3 minus BC is 2y. So BC bracket root 3 minus 1 is 2y. So BC is 2y upon root 3 minus 1 meter. But we are not interested in BC. We are interested in AB. We have already found out. So AB is equal to BC, which is 2y root 3 minus 1. But the proving in the question it is stated the height of the tower is y bracket root 3 plus 1. So there is no denominator there, means I will rationalize root 3 minus 1, root 3 plus 1, root 3 plus 1. So it is 2y root 3 plus 1 root 3 a minus 1 and a minus b into a plus b, which is 3 minus 1 2 gets cancelled. So it is y into root 3 plus 1 AB the height of the tower. I hope this is understood. We had to prove, but ultimately we are doing the same thing, two triangles, right? Tan as per the given things or whatever relation, AB is common, so we went for tan and we equated and we got the result. Let us move to the next one. Next, the angles of elevation of a top of a tower from 2 points on the ground at a distance a meters and b meter from the base of the tower in the same straight line with it are complementary. Prove that height of the tower is root AB meter. There is no angle of elevation given. Slightly different question. No angle given. Only thing they mention is what they have mentioned. I'll repeat. The angles of elevation of the top of a tower from the 2 points on the ground at a distance A and B from the base. Now, the distance of these 2 points from the base is given. BC is A meters, BD is B meter, and a relation between these 2 angles are given. What is the relation? They say the angles of elevation are complementary. Means angle ACB plus angle ADB is equal to 90 degree. Complementary means sum of the 2 angles is 90 degree. You have to prove height of the tower is root AB. Now in such question, as the angles are not given and we can't find because they are not mentioned at all, so obviously a right angle triangle taking tan, sine, cos won't come into picture. We have to use this relation. Angle ACB is 90 minus ADB. Now we want height. This is A, this total is B. So obviously this is a common side, means I am going to go for tan of this angle, then only I can relate AB and BC, the perpendicular and the base. And because I want tan of this angle, I will take tan of both these angles. Tan of angle ACB is AB upon BC. Now tan of 90 minus theta, complementary angles studied in 9th standard. Tan of 90 minus theta is cot theta. So AB upon BC, cot of ADB will be base upon perpendicular. Base upon perpendicular. So what we get here is AB square is equal to BC into BD. AB square will be A into B, which is given in the question, and therefore AB is square root of AB meters. That is what the proving answer is, square root of AB meters. Here we never applied a right angle triangle ka concept as angles are not given. I hope this is understood. If this is not done, we won't be able to get the answer. So tan of 90 minus theta is cot theta. Tan of 90 minus theta is cot theta. Next, question number 7, slightly different. From a point 36 meter above the surface of a lake. So if I take this as a surface, this has 36 meter above the surface of the lake. The angle of elevation of a bird is observed to be 30 degree and angle of depression of its image in the water is observed to be 60 degree. So this is the position, say, of the bird. We want to have a angle of elevation. So this angle of elevation is 30 degree. This is lake. And the angle of depression is 60 degree. How this figure is understood, I'll explain again. It is 36 meter above the lake. So I took 36 meter. The lake starts here. So this is water below it. From here, the angle of elevation of the bird is 30 degree, and the angle of depression of its image will be inside the lake. This image ka depression is 60 degree. Both the angles should be with respect to the line of vision, which is AE. AB 36 meter above the lake. AE perpendicular to CD. F is the image of the bird in the lake. Now the image ka distance from the surface will be equal to the height of the bird from that particular surface. So here obviously CD will be equal to CF. In dimensions, what is known is this much. Find the actual height of the bird above the surface of the lake. Actual height of the bird above the surface of the lake means I want CD. CD. AE perpendicular to CD. Therefore, quadrilateral ABCE is a rectangle. Therefore, AB is equal to CE is equal to 36 meter. Any other dimension given in the question? No. So, I'll take this as X. Let DE is equal to X meter. So, in right angle triangle AED. Now why will I select this triangle? Because this AE is a side common to this and this triangle. I'll get AE in terms of X. So tan 30 will be perpendicular side upon base. So it is 1 by root 3 X upon AE. So AE is X root 3 meter. We got AE. Now the next triangle, in right angle triangle AEF, because DE is X, okay, AEF will go and then we can substitute X. Firstly 60A, A is the base, EF is the perpendicular. So tan 60 will be EF upon AE, which is root 3 EF upon AE. So EF is equal to AE root 3. We already know AE, which is x root 3. So x root 3 into root 3, which is 3x. We got EF in terms of x. But what is EF from the figure? It is CF plus EC is equal to 3x. CF is equal to CD, which we want to calculate. CD plus EC is 36 is equal to 3x. So what is CD? It is 3x minus 36 meter. CF and CD are equal. So we got CD as 3x minus 36. But I don't want anything in terms of x. I want a proper number there. How will I calculate the number? Anything which is there, which we can use for solving. We know CD. CD, we got it in this way, but we also know CD as what? It is CE plus DE as 3x minus 36. What is CE? 36. What is DE? X is equal to 3x minus 36. So it is 36 plus 36. So it is 72 is equal to 2x. So x is 72 upon 2. X is 36 meter. We want, the question says, actual height of the bird. So actual height of bird is CD from the lake, which will be x plus 36. So 36 plus 36, which is 72 meter. I hope it is known, understood properly. The figure is very, very important in this question. And secondly, we should consider this. This height will be equal to this height. If you miss out on this, you won't be able to solve the question. Figure should come correctly. The image will be inside the lake and the image distance from the surface will be equal to the actual height of the bird. Okay, let us move to the next one. Which one we can do? Last one, 8th one. Question says, in the given figure, from the top of a building AB 60 meter high, the angles of depression of the top and bottom of a vertical lamp post are 30 and 60. Okay, the figure is there, already drawn. A, B, C, D, 30 and 60 degree. What is AB here? Top of a building. AB is the building and AB is 60 meter. CD is the lamp post. CD is the lamp post. We want to calculate the height of the lamp post. Obviously, if I want to consider these angles of depression with respect to these two lines, this angle or this line, for this line, so we have a base, we have a vision, so this will be 60 degree. But for this, we will have to draw a perpendicular, then only this 30 degree will be this 30 degree. So let us mark this as E. DE is perpendicular to AB. Let CD is equal to x meter. Quadrilateral BCDE is a rectangle. Therefore, BE is equal to CD is equal to x meter. So this also is x. This is x, which we want to calculate. Obviously, two triangles are formed. Triangle ABC and triangle AED. So, in right angle triangle ABC, tan 60 will be perpendicular upon base root 3. AB is known 60. BC is not known. So BC will be 60 upon root 3, which is 60 root 3 upon 3, which is 20 root 3, which is BC. As BC is 20 root 3, therefore DE will also be 20 root 3, opposite sides of a rectangle. In right angle triangle AED, tan 30 will be AE upon ED, 1 by root 3 AE. What will be AE? It will be AB minus BE upon ED, 1 by root 3. AB is 60. BE is x, which we have considered, upon ED or D is 20 root 3. So 20 root 3 upon root 3, 60 minus x, root 3 cancels, x will be 60 minus 20, x is 40 meter. So height of lamp post is 40 meter. That is what they have asked, height of the lamp post. Also, they want horizontal distance between AB and CD. Horizontal distance between AB and CD means they want BC. BC is 20 root 3. That also we have calculated in terms of root 3. So that brings us to the end of the trigonometry heights and distance chapter. I hope whatever questions we have done, everyone has understood. Any doubt related to this particular topic, you can post it in the comment. Thanks for watching the channel. Please subscribe, like and share the same. Thank you very much.